So suggesting to us that since hydrogen have the subscript 1, that this subscript 1 that hydrogen has is actually the valency of this radical. Okay, hello guys, I'm Genius. You're welcome to my channel once again, and in today's video we're going to be looking at how to write and name trinary compounds, more specifically trinary inorganic compounds. In the previous video we also learned how to write and name binary compounds, and I taught us using the concept of valency how to write binary compounds, and then using the IUPAC system we also looked at how to name binary compounds. Are we together now? And in today's video we are looking at ternary compounds, because binary compounds are compounds that contains two elements only, two different elements only. And then for ternary compounds, they are compounds that contains three different elements. Are we together now? And so the method of writing the chemical formula for ternary compounds is not different from that of binary compounds. However, the method of naming becomes different. Are we together now? And so for us to understand fully well the concept of ternary compounds, or how to name ternary compounds, we have to first of all learn about ternary acids, because all ternary compounds are derived from ternary acid. And if we can understand ternary acid, it becomes more easier for us to understand trinary compounds. Are we following now? All right, so let's dive right into it. So like I've said before, ternary compounds are derived from what? From trinary acids. Trinary acids. Are we together now? All right, now ternary acids are compounds that actually contains hydrogen, oxygen, and any other element in the middle, and they are in such a way that hydrogen is always the first element, followed by any other element, either a metal or a non-metal, and then oxygen must be the last. Are we together now? So I'll just give us some examples of ternary acids. For example, we have HNO3, all right, ternary acid. Then we have H2SO4, and we also have H2CO3, and then we also have HClO3. Are we together now? We can also have H2SO3. Okay, and so these are ternary acids. You can now see that hydrogen is the first element in each of these acids, and then oxygen is the last. Are we together now? Any other element is in between or is in the middle. And so whenever you see this kind of compounds, they are acids. They are ternary acids more precisely. Are we together now? All right, so the first thing we are going to look at here is to analyze these ternary acids and look at how they'll be useful to helping us in naming ternary compounds. Now, the first we're going to do is that we're going to look at the ionization of this acid. For instance, if we have HNO3 in the aqueous state, okay, if you want to ionize, it's going to give us H plus and then plus NO3 minus. Now this is from Arrhenius theory of acid and base. You can see that the reason why I gave this NO3 negative sign is because from the Arrhenius theory, when an acid dissociates in water, the only positive ion is hydrogen ion, and so if hydrogen ion is the only positive ion, other elements will bear negative charge. Are we together now? And that's why it's this way. So let me also do for another one, H2SO4, also in the aqueous state. Okay, nicely to give us H plus, hydrogen ion must be the only positive ion, then other elements there will just form negative ion. I'm going to give it 2 minus. Are we together now? To balance the equation, I'm going to put this as 2, and the equation is now balanced. So what we're going to be looking at here that will be very useful to us in naming ternary compounds is this other substances here. Are we together now? Firstly, you have to know that these are two atoms that are carrying charges, and in chemistry they're actually called radicals. They're actually called what? Radicals. Okay, so radicals are a group of atoms that bear a charge and act as a single unit. So very important, they bear charge, either positive or negative, and they also act as a single unit. Those are what are radicals. And my question to you is, why is it that I actually use two minus here and here I use minus? Now I hope you are aware that these two minus means that the oxidation state of this is -2, and this minus means that the oxidation state of this is -1. And remember that if you remove the negative charge or the charge, what you have left is the valency. And so it means that the valency of this is 1 and the valency of this is 2. So are we together now? So my first question is, why did I use minus and why did I use two minus here? Now, if you remember from that first video I did in binary compounds, you will understand that when we actually combined elements to form compound, we make use of their valency in such a way that the subscripts of a particular element in the compound is actually the valency of the other element. What I mean, like I did an example on Na2O. We learned that the subscript of sodium is 2 and that of hydrogen, of oxygen rather, is 1, and that simply means that the valency of oxygen is 2 and the valency of sodium here is 1, because in getting the chemical formula like this, we actually interchange the valencies to give us the subscript that makes for the correct chemical formula of the compound. And so because the subscript of sodium here is 2, that is the valency of oxygen. And so look at this. The reason why we are bringing this into play is that, look at the subscript of hydrogen is what is 1 here, and that of hydrogen is what is 2 here. That suggests to us that since NO3 is a radical, okay, radical group of atoms, they are group of atoms, okay, group of what atoms, and they behave like single unit, they act as single unit, that's their one. We are not differentiating nitrogen and oxygen here, they are the same, okay. We take them as one, and so we will have to find their balance. Are we together now? So suggesting to us that since hydrogen have the subscript 1, that this subscript 1 that hydrogen has is actually the valency of this radical, okay. Are we together now? And so if I want to look at the chemical combination between hydrogen and NO3, remember hydrogen valency is always 1. I will put 1 on top. This one will be 1 now, because for what we are seeing, so we now interchange them, okay, and that will end up giving us what? Give us H. So it will give us HNO3. Are we together now? Because the valencies are 1 1 respectively. Now coming to this one, you see that the subscript of hydrogen here is 2, and that simply means that this subscript of hydrogen belongs to this radical SO4, and that is why I use 2 minus here and minus here, because since the subscript of hydrogen here is 1, the valency of this is going to be what? 1, and since the subscript of hydrogen here is 2, the valency of this is going to be 2. However, because in an acid, hydrogen will be the only positive ion, okay, other atoms are going to become negatively charged, and that is why I put them minus or negative. I use negative to attribute their valencies. Are we following now? So it simply means that if I can know the correct chemical formula of ternary acids, I can actually predict the valency of the negative radical ion that comes from that acid, because it is these radical ions that combine with metallic ions or ammonium ion to form more ternary compounds, and those are what we call salts. Because when we say salt is formed when metallic or ammonium ion displaces hydrogen ion from an acid, so salt is formed. For instance, instead of this H2SO4, if I now end up seeing Na2SO4, you see now that this sodium atom, it has displaced hydrogen from this, and so this becomes a salt. Are we together now? Maybe subsequently I'm going to be doing a video on acid base and salts, but till then let's just continue with what we are looking at now. So you can now see that what we are trying to get here is that from ternary acids we can predict the valencies of the acid negative radical ion or negative acid radical ion that forms other ternary compounds. Are we together now? All right, so we're going to be looking at how to write the correct chemical formula of other ternary compounds apart from the ternary acids. Remember, I had said that other ternary compounds are derived from the ternary acids, and so we just made use of the knowledge of the fact that from the ternary acids we can be able to predict the valency of the negative acid radical ions that are contained in other ternary acids by the displacement of hydrogen ion, okay, by the metallic ions. Are we together now? And so let's look at that now. So I'm still going to make a list of some of the ternary acids again. So we have HNO3, and then we have H2SO4, and then we have H2CO3. These are the common ones. We also have HClO3. Okay, I think I might stop here for that. Now let's now look at the combination. All right, let's look at the combination between sodium and SO4. Okay, sodium and SO4. Now the first thing we're going to do is that we're going to get the valencies, because to write the correct chemical formula of any compound you need valency. Valency is what you need. And remember, in that previous video I had explained valency beyond the knowledge of the fact that it's a combining power of elements. I gave us the practical definition of valency. Are we together now? And so the valency of sodium, we all know, is 1, because from the atomic structure we get that the number of atoms in the valence shell of sodium is 1, and so because it's going to lose 1 electron, the valency becomes 1. So I'm going to bring sodium, all right, by the valency above it, then bring SO4. Now look what we're going to do now. We're going to check from which acid is SO4 coming. We now see that it is from H2SO4, and the valency of this SO4 will actually be the subscript of hydrogen, and so it's 2. So that makes me to know that the valency of SO4 is what, 2. Now I'll go ahead to interchange the valencies. Because this act as a single unit, I'm going to put them in brackets. Are we together now? Then I'm going to interchange these valencies to become the subscript of the other elements. Are we together now? And this will end up to give us what? Na. Now this is going to be 2. Then this is going to be, this is going to be SO4. I'm not going to put the bracket again because it's 1. If it is any other number apart from 1, then I'm going to retain the bracket and keep the valency, which becomes the subscript here. And so this becomes the chemical formula for the combination of sodium and this acid radical. Are we together now? So we're going to look at another example. All right, so what if I want to look at, let me say calcium and this same SO4. How would the compound look like? So let me clean this off. Now let's say if you are dealing with let's say calcium is combining with SO4. How is it going to look like? Okay, so calcium is Ca, and we know that the valency of calcium is what? Is 2. The valency of calcium is 2. So to get the chemical formula, we also need their valency. So we get that this is what? Ca, write 2 above, and then this is also SO4, write 2, and then we change the valencies. Remember, this is a single unit, so I'm taking this here. Are we together? So this is going to give me what? Ca2. Then we're going to have what? SO4, and then we have 2. Are we together now? So what I'm going to do now is that since something can go between them, we're going to cancel out. Please stay tuned to check out the video on empirical and molecular formula, which I'll be dropping very soon. It's very, very important. So what I'm doing now. Alright, so we're going to have this what? Cancelling these 2 out, we're going to have CaSO4. So you see that this becomes the chemical formula for calcium and SO4. Meanwhile, when it was sodium, it was NHSO4. So it is not always a more that you must put 2. It just depends on the type of element you are using and the valency, of course, which that element has. Are we together now? All right, so let's look at the combination of let's use this acid radical NO3. All right, let's say we are combining potassium, so let's say K, potassium, and this NO3. So we're going to also use the valencies. K, and the valency of potassium is 1, and then we have NO3. Let's say the acid from whence this NO3 is coming is from HNO3. And that simply means that since the subscript of hydrogen is 1, the valency of this acid radical ion is going to be also 1. So we take it to be 1. Make sure you put this as a single unit by putting it in brackets, and then we now interchange the valencies with this subscript. This become K. Instead, we will not put 1 K, NO3. So this is called the chemical formula formed between potassium and NO3. Are we together now? And you can now see that it is very, very simple for you to, if you know the valencies of the acid radical ions, so you see that it will be helping you to get the correct chemical formula for ternary compounds. So we're going to try to write the chemical formula for the ternary compounds for the elements which have more than one valency, just like we did for the binary compounds. And let's look at a few of them. Now let's look at lead. Lead is Pb. Lead has two valencies, 2 and 4. Copper Cu has two valencies, 1 and 2. Iron has two valencies, 2 and 3. I'm going to stop here for now. I listed more examples in the previous video. You can check it out as well. Alright, so let's look at the combination of lead Pb and NO3, and then II. Look at the combination of copper and let's say SO4. Okay, so the solution for the first one is okay, we're going to bring out lead. We're going to be using the valency 2 for lead. We're going to use 2. Okay, and then we're talking about NO3. So we go to the acid. What's the valency? What's the subscript of hydrogen is 1. And so because the subscript of hydrogen is 1, the valency of NO3 becomes what? 1. And so I'm going to write NO3, but because they are radicals, I'm going to put them in bracket because they are single units, and I put their valency above. Are we together? Now I'm going to interchange the valencies to give the subscript of the two different substances. And so this is going to give me what? Lead, and the subscript is 1, so I won't put the 1. Then I'll open the bracket, NO3, close the bracket, and then this 2 comes over here. So I won't do any other thing because 1, 2, I can't simplify further. So this becomes the chemical formula for the combination of lead and NO3. Are we together? Yes. All right. So the next thing is copper. Let's look at copper. Copper Cu, and then let me not use SO4. Let's use CO3 for copper. All right. CO3 copper. All right. Copper and CO3. Now we know that this CO3, what would be the possible valency of CO3? Because the subscript of hydrogen from whence this CO3 is coming from is 2. That goes to tell us that the valency of CO3 will be 2. Are we together now? And so we're going to be using the valency of copper, which is 2 as well. All right, copper 2, and then we have CO3. And put them in bracket. The valency is 2. Now we interchange the valencies to give the subscripts. That will now give us Cu2, and then this is in bracket CO3, then also 2. And so we are going to cancel out because something can go to get the simplest formula. All right, please you don't have to miss the video on empirical molecular formula. So we have Cu, then we have what? CO3. And this becomes the chemical formula for the combination between copper and CO3. Are we together? So the next we're going to do now is how to name ternary compounds, starting with ternary acids, and then we name for the other ternary compounds. Are we together? All right, so we're going to be looking at how to name ternary acids. Are we together? And I've given us a few rules here that will help us to name ternary acids. The first thing we have to note is that we're going to use Latin prefix to show how many oxygen atoms are contained in the acid, and then we change the oxygen to ozo. Then the name of the middle element, we change the name of the middle element by adding the suffix ate. Finally, we write acid to represent the hydrogen atom or atoms. All right, now this Latin prefix, I'm going to write them out. We have mono represents 1, and then we have di represents 2. We have tri, which represents 3. Okay, so let me add here. Then we have tetra, which represents 4. We have penta, which represents 5. We have hexa, which represents 6. Then we have hepta, which is 7. Octa, which is 8, and none, and so on. All right, so those are the Latin prefix. And so to name this acid, let's start with this first one. To name this acid, notice that we start from the right to the left, so we're starting from here. All right, so we'll start with the oxygen. How many oxygen are there? We have 3 oxygen atoms, and so we use the Latin prefix. Where is 3? Is 3? 3 is tri. So we're going to write what? Tri. Then oxygen change for oxygen to become oxo, so it becomes trioxo. Then the middle element is changed by adding the suffix ate. Instead of nitrogen, we're going to write nitrate, so put nitrates. All right, and I've not written one of the other rules that are helpful because I don't think I have to write it down. Now the next thing you have to do now is to write the oxidation state of the middle element. Are we together now? Yes. And for nitrogen, to get the oxidation state of nitrogen in this compound, I'll have to write HNO3 because it's a neutral atom. I'm going to put it to be equal to 0 because all compounds, the sum of the oxidation state is equal to 0. Okay. All right. Hydrogen's oxidation state is +1. That of oxygen is -2. Always, except for hydrogen in metallic hydrides and for oxygen except in hydrogen peroxide. So this is going to go +1 times, rather +1 plus now nitrogen, then plus oxygen is -2, then times 3 because it's thrice, equal to 0. All right, so this gives us 1 plus n. Minus times -2 times 3 is -6, plus times minus is minus. So this is what -6 is equal to 0. Now we are going to have this to be, let me bring it up. We have n, and then we have +1. I'm shifting them, -6, then equal to 0. +1 minus 6 is actually equal to -5 and equal to what? 0. So this becomes n is equal to +5. You must put the charge. So that's the oxidation state of nitrogen in this compound, and we are going to write it in the Roman figure. All right, so trigonnitrate, the oxidation state of nitrogen 5. Then we'll now put, finally write the acid to represent hydrogen. No, we don't write hydrogen, we write acid. We are following the IUPAC system, so we're going to put acid, and that's the name of this acid, triosonitrate 5 what? Acid. So let's get that of this. Now we have this oxygen is 4, and 4 means tetra, so we start with what? Tetra. Then instead of oxygen, write also tetra also. Sulfur becomes what? Sulfate. Tetra also sulfate. The next thing to do is to go get the oxidation state of sulfur in this compound, and quickly let's do that quickly. So we have that H2SO4 will be equal to 0. Okay, to be equal to 0. Hydrogen is always +1, but now it's 2. So we have times 2 plus sulfur plus -2 times 4 equal to 0, and that's going to give us what? This is 2, then plus -2 times 4 is -8, plus times -8 gives us what? Gives us -8. All right, equal to 0. I'm going to shift them so I can add or work on the numbers. That's 0. Then I have x plus 2 minus 8 is -6 is equal to 0. That simply means that x become equal to plus what? 6. So we're taking the number 6. So we'll put it tetra sulfate what? Vi, which is 6. Then we'll put what? Acid. That's the name of this compound. Are we together now? And I would like you to try for this and this and drop your answer in the comment section. Now this is how we can name ternary acids. You just need to use the Latin prefix to show how many oxygen atoms are contained in the acid, and then you change the oxygen, the oxygen as the name of oxygen to oxo, and then followed by writing the middle elements, but now with the suffix ate, and followed by the oxidation state of that middle element, and then instead of hydrogen we'll now write acid. All right, so please do well to drop this in the comment section, and I'll see what you have. For now, let us move on to how to name other ternary compounds. All right, so we're going to be looking at how to name other ternary compounds apart from the ternary acids. All right, now it's the same we are going to be following. Are we together now? Nothing much, but just that we don't have number 4. I'll actually change it to 3 4, meaning that this is the first one. You start with the first element retaining its name. Are we together now? And then the now start again from here. So it means that to name this compound, we're going to start with this first element. Unlike the ternary acid where we started from here to here, we're going to start with the first one, then we'll move here and then to this point. Are we together now? So we're going to name this first before you go back here and start naming. So to name this compound, we're going to put it as what? This is because this is sodium. So write what? Sodium, then tetra, because it's 4 oxygen. Sodium tetraoxo. Then this is what? Sulfate. And then remember the sulfur is 6. Okay. All right, that's it. Sodium tetraoxosulfate 6. We don't put any acid because it's not an acid. Are we together now? And remember, I have gotten the association of sulfur is +6 in SO4. In NO3 for nitrogen is 5. So we're going to start with this. This is K and is potassium. So write what? Potassium what? Potassium. This is what? Triazo. Okay. Then nitrogen becomes what? Nitrate. And the source of nitrogen you can confirm is what? 5. Are we together now? Nitrate 5. And that's all. Potassium trianitrate what? 5. Then very important, this is lead. Now remember that when we derived the or when we got the correct chemical formula for this, we noted that lead had 2 valencies, 2 and 4. However, we used the valency 2. So just the same way we did for the binary compounds, when you want to name this, you have to look at if the first element actually has more than 1 valency. If it does, then you are going to be specifying the valency you use. And for this is lead 2. And how will I know that this guy is coming from HNO3 and since the substitute of hydrogen is 1, it means that the valency for this is going to be 1, and so 1 will be here. And since this 2 is the subscript of this, means that this subscript belongs to lead, and so this subscript here is the valency of lead. So I'm going to call it what? Lead. Okay, lead 2. All right, lead 2. Then also write what? Triazo nitrate. Triazo nitrate 5. So that's the name of this compound, lead 2 triazo what? Nitrate 5. I'm moving on to this as well. All right, so this is CuCO3. Remember, copper has valencies 1 and 2, and remember that this CO3 is coming from this acid H2CO3. The substitute of hydrogen is 2. That means the valency of this is actually 2. Are we together? So if it happens that this is not having any subscript and this is not having any subscript, meanwhile the valency of this is 2, it simply means that the valency of this will also be 2. Although we have done this previously. Are we there now? Yeah, that the valency here is 2. So we are making use of copper 2, and so we're going to write it as what? Copper 2. Then this will now be what? Triazo. Copper 2 triazo. Then carbon become what? Carbonate. I will need to go get the association of carbon here. Are we following now? So we can get that by saying CuCO3 is equal to what? 0. Are we together now? Copper here is +2, so we write 2 plus carbon. We're looking for carbon plus. All right, so this is going to give us -2. All right, so this is -2 times 3, and that's equal to 0. Now -2 times 3 is -6, so you have 2 plus C. Now this is -6 in the bracket now, so plus times -6 will give us -6 as well, equal to 0. All right, that will end up to give us let me shift this to this. Okay, so you have carbon, then +2 coming first, then -6 is equal to 0, and so you have carbon +2 minus 6 is now equal to -4, equal to 0. That simply means that the association of carbon here becomes +4, and so we call this copper 2 triazo carbonate what? Carbonate 4 IV. And that's the name of this compound. And so this is how you can simply name ternary compounds with ease. Just follow the rules and it makes it simple and short. Are we following now? All right, so we have come to the end of this video. I would like you to please go over the video maybe twice so that you can fully get abreast with what we are doing. Are we together now? And in case you have not subscribed to the channel, also make sure you subscribe, like the video, and share to your friends whom you think might find it useful. Alright, so I'll be dropping a video very soon on empirical molecular formula, and please stay tuned as we have a lot of things for you.